Okay, so we're going to look at finding the areas of sectors and segments using radians. So hit pause, make some notes when you're ready, hit play again. So we're going to try and work out the area of the sector and segment using radians. Using radians makes it a lot easier for us. So the sector we're going to look at in this circle is this one here. Whoops. That one. Well, that's not too bad actually. So that sector we're looking at is the sector AOB. So we want to find the area of sector AOB. Now at GCSE, you don't make notes on this. At GCSE, to find the area, what we would have done was we would look at theta, the angle that subtends this area here, as a part of the whole total circle. 360 times the area of the total circle, which is pi r squared. So that's what we would have done at GCSE. I'm sure you remember that very well. We're not going to do that now. That's gone. What we'll look at is using radians. So to use radians, we're going to look at the ratio of the area of the sector, sector A, as a part of the total area. That's going to be equal to the ratio of the angle of the sector, which is going to be theta, divided by the total angle. So the area of the sector A and the total area of a circle is pi r squared. Angle of the sector is theta, and that's going to be divided by the total angle. Now that's 360 degrees, but in radians it's 2 pi. So A is going to be equal to theta divided by 2 pi times pi r squared is dividing on this side, so it becomes multiplying on this side here. So it'll be times pi r squared. If I just change color, I think I'll use green this time to cancel. So I can cancel pi on the top and pi on the bottom. If I go back to my red, that means A is going to be equal to theta r squared over 2. You can write that as half of r squared theta. So either one of those, you can write it down as that. Okay, good. So that's how we find the area of a sector. A is equal to theta r squared over 2, or half r squared theta, either way around. So hit pause, make some notes when you're ready. Hit play and we'll look at some examples. Okay, so in this example, the area of the minor sector AOB is 28.9 centimeters. This is our minor sector here we're looking at. We just outline it, whoops, like so. So we're looking for the area of that sector. They give us the angle AOB is 0.8 radians. Calculate the value of R. So we know that A is equal to a half r squared theta. So what do we know? We want to find R, we know A, and we know theta. So if we plug that in, so that means that 28.9 is equal to a half times r squared times 0.8. So 28.9 is equal to, well, the half of 0.8 is 0.4. So it's going to be 0.4 r squared. That means r squared is equal to 28.9 divided by 0.4, and so r is going to be the square root of that, square root of 28.9 over 0.4, and your calculator will tell us that the solution which must be positive, is 8.5 centimeters. Okay, good. So first example. So hit pause, make some notes, write the example down, and when you're ready, hit play again. Okay, let's have a look at this example. Plot of land in the shape of a sector with radius 55 meters. The length of fencing that's needed to enclose the land is 176. Calculate the area of the plot of land. So the length of fencing is actually the perimeter. First things first is to make a sketch of this. There we go. So that's our sector. We've got our radius here, 55 and 55, and then we've got a length of arc here, which we can calculate because we now know the perimeter. So P equals 176 meters. That means 176 is equal to 55 plus 55 plus AB. So AB is going to be equal to 176 minus 110, which is 66 meters. So that's our arc there, 66 meters. Okay. Now we know the length of the arc. That's going to enable us to find theta. When we find theta, then we can use our formula. Now, I know the length of the arc. I know a formula for finding the length of the arc. I know the radius. So if I use that, L is equal to r theta. That means the length of the arc 66 is equal to 55 times theta, or theta is equal to 66 divided by 55. When I work that out on my calculator, I get 1.2 radians. So that's the length of the arc, 1.2 radians. Sorry, the angle of the arc, 1.2 radians. Now, I can use that then to find the area of the sector. A is equal to a half r squared theta. I know the radius, 55. I know the angle, 1.2. So that's going to be equal to a half times the radius squared, 55 squared, times the angle, 1.2. I work out my calculator and you should get 1815 square meters. So hit pause, make some notes, get the example down. When you're ready, hit play again. We'll look at another example. Okay, so we've been working out the area of the sector. We can also work out the area of a segment using radians. Now the area of our segment here we're trying to find is this hashed portion. So any ideas on how I would go about finding the area of this segment? Well, when I take a look, let me just change this into a different color. Let's look yellow. I can look at my sector here, AOB, and that includes that little segment. So that's the whole sector. If I take away this triangle, that's also AOB. Let's see if we use blue. So the triangle here, if I subtract that from the sector, then I'm going to be left with the segment, the area of the segment. So let's do that then. Let's write that down, red pen. So I can say, if I have enough room, the area of the segment is going to be equal to the area of the sector minus the area of the triangle. So the area of the sector first, the sector AOB, that's going to be equal to a half r squared theta. Yep, so we've got our r there and theta. And the area of the triangle then, AOB, that's going to be equal to, Now, how do I find the area of a triangle? Anyone remember formula for area of a triangle? It's not a right angle triangle. The area of any triangle is given by a half of AB, the sides, times sine of the angle in between, sine C. In this case, the sides are R and R, so it's going to be half R squared. And the angle in between them is theta, so sine theta. So we've got our two formulas, so we can say the area of the segment then, therefore, the area of the segment, it's going to be equal to a half R squared theta, that's the whole sector, minus the area of the triangle, a half R squared sine theta. And that's pretty much job done. I just need to simplify, see what's factorize what's common to both, and that's a half of R squared, leaves me with theta minus sine theta. So that's the area of the segment. And you might want to make some notes on that, I think. Do a sketch and make some notes. So area of the segment is the area of the sector minus the area of the triangle. Good. Hit pause, make some notes. When you're ready, we're going to look at an example. Okay, this example, it says calculate the area of the segment shown in the diagram below. We're given the angle, theta, pi by 3. We're given the radius, and that's all we need. So the area of the segment, formula's still up there. So we can say area of segment that's going to be equal to a half R squared theta minus sine theta. I always write the formula, it sort of leads me on, I can substitute then. Also it helps me remember, so in future then I don't have to refer to a booklet. Half times the radius squared, 2.5 squared, times theta, pi by 3, minus sine of theta. Okay, now I always feel that if you can enter all this into your calculator in one go, do it. If not, we'll do what's in the brackets and then multiply. But if you can enter it all in, I do it now. So you end up with a half times 2.5 squared times, and this is why I think it's best, 0.1811. It's best to put it all in, because then you get 0.1811 and there are more digits to put in there. And if you approximate it now, you will be losing something of accuracy in the final answer, which should be 0.57. Okay, so if you can enter all that in the calculator and get 0.57, fantastic. Miss a step. Good. Hit pause, make a sketch, write the solution, and we'll look at another example then. Okay, let's have a look at this example. So they've given us a diagram, and in the diagram AB is the diameter, so that runs along the base there, AB. Radius is R, so we can write that in actually. R is there, or R is there, or R is there. That's our center. Given that the area of the triangle AOC, I'll tell you what, let's get a different color. So the triangle AOC is this one. So the area of the triangle AOC is 3 times the area of the shaded segment. Show that 3 theta minus 4 sine theta equals 0. Okay, so let's go back to red and let's have a look. What's the area then of the segment? Area of the segment. Radius is R, angle is theta, so it's going to be equal to a half R squared theta minus sine theta. They've given us the information on the area of the triangle AOC, 3 times the shaded segment. But what is the area of the triangle AOC? Now, in order to find that, I know the radius here. I know this angle here. Yeah, that's going to be 180 minus theta. So I've got the angle in between two radius, so I can use my formula for the area of a triangle, which is a half AB sine of the angle in between sine C. And in this case, it's equal to a half r squared sine of 180 minus theta, or pi minus theta. Pi minus theta. Should really have written pi there because we're working in radians. Now, there's a fact when I draw my sine curve, which I'm going to use for this, try and make it as large as possible. So there's my sine curve, looks like that. That's pi, and that's 2 pi. Now, any angle here up to 90 degrees, as I cut across, I keep going to there, any angle there, call it theta, is going to have the same result as here, which is pi minus theta. So if I have pi minus theta, I can replace it with theta, as I'm going to do in here. So that means that's equal to a half r squared sine theta. So the area of a segment, half r squared theta minus sine theta, is a funny looking theta, let's adjust that. And area of the triangle is a half r squared sine theta. Now they tell us here that the area of the triangle AOC is 3 times the area of the shaded segment. So let's write that down. Area of triangle AOC is equal to 3 times the area of the segment. So that means a half r squared sine theta is equal to 3 times a half r squared of theta minus sine theta. Okay, so I can cancel some of the things that are the same on both sides. Let's get a different color pen. Let's go green again. So I can cancel the r squareds. I can also cancel the half. So that leaves me with, green back to red, that leaves me with sine theta is equal to 3 times theta minus sine theta. Expand and simplify. Sine theta equals 3 theta minus 3 sine theta. And so if I take the sine theta over the other side, it becomes minus. So 0 is equal to 3 theta minus 4 sine theta, which is what we've asked for in the question. I can reverse that to make it look like the solution. That means 3 theta minus 4 sine theta is equal to 0, which is exactly what they wanted in the question. Good. Hit pause, make some notes, and yes, I can tell you're ready for some questions now, and then we'll go on to questions. Okay, so you're going to be doing exercise 5D. If you're confident, then on question 1 you can do just A and D. If not, if you want more practice, go through the others. You're going to be very quick. Leave your answers in terms of pi. Question 2, do A and B. Question 3, A and C, and then start working through the worded questions. Quite a few today. Okay, it takes you up to question 17. Okay, so exercise 5D, page 125. Off you go. Good luck.